Okay, so let's get started. We're going to be taking a look at working with our idle control tuning in this training module. Now this module is going to be focused on the concepts and the basics of idle control. We're essentially doing an overview of an idle control routine. We're going to be moving into specific idle control tutorials here, following up this tutorial, taking a look at mechanical-based idle control, pulse width modulated idle stepper motor based idle control, as well as drive-by-wire idle control. So there are going to be a couple different forms of idle control that we can program and work with our Motec. We'll be taking an overview here and understanding conceptually what's going on, so we have a better idea as to how to approach dealing with those individual types of idle control routines as we're going to go through here in the future training modules. Let's jump in from our fuel tuning page here, and let's move over here into our idle tuning page. This is going to be where we program and work with all of our idle control parameters within the idle control routine. Now, the first things first within the idle control tuning, we need to establish what we're actually doing with idle control. So the way the idle control is going to work, we're going to have our idle target table here, and that's going to be our idle aim main. Now this is the starting point of where we want our engine to idle at within the idle operation. So whether we're dealing with a 3-cylinder engine or a 12-cylinder engine, we'll call out our desired engine RPM here. Now, the RPM is going to essentially translate into a certain level of torque output from the engine to maintain that desired idle speed. So when we're talking about idle control, we are saying we want the engine to run at a certain engine speed, but what we're indirectly calling for is the control of the engine's torque output. If we're finding that we have more torque in idle conditions, the engine speed will naturally raise up. It'll go higher than our desired target here. If we have less engine torque, the engine will idle lower and will be lower than the desired idle speed. So what we find within an idle control routine is that we're influencing the engine's torque to hit the desired idle speed that we're asking for here. Now there are other idle offsets, so meaning other idle RPM adders or subtractors that can work against our table here, but this is essentially what we're basing our whole entire idle control around: a certain idle target, and then we manipulate our engine's torque output around that. So when we're talking about engine's torque output, we're going to find that we have 3 factors that will influence the torque. We have airflow, we have fuel, we have spark timing. Now when we're talking about idle routine and idle control and the engine idling, we are going to typically call out stoichiometric 1.0 lambda as where we want to run our fueling target at, and ultimately our fueling at for whatever engine we're trying to control. So when we're talking about idle control routine, fueling is typically not going to be a factor that we change or do anything with, because it's something that's going to say essentially a constant. So when we're talking about manipulating our engine's torque output in idle conditions, we're really talking about manipulating our airflow and our spark timing. Both will have a substantial effect on what the engine's torque output is going to be. Now let's break this down a little bit further so we understand what we're referencing when we're talking about airflow and spark timing in terms of our idle control. If we look at OEM programming from Ford or GM, we're going to find that they reference what they call airflow or spark timing in terms of control as slow path or fast path. A slow path control is going to be our airflow based control within idle control routine. Our fast path would be spark timing. Now, the reason why it has the name slow or fast path is because when we're talking about, and specifically slow path, airflow based control, moving the airflow will have a slower effect or result on the engine's torque output. So if we move around how much airflow is coming into the engine within the idle control routine, it's going to have an effect on the idle, but it's not going to have as quick of an effect. So it takes a little bit of time for us to move either the idle stepper motor, idle control motor, or the throttle blade with drive-by-wire to get the desired idle result that we're after, to try to get the engine's torque output regulated to run at that desired idle speed. So we have our slow path control, which is airflow based, and our fast path control, which is going to be spark timing based. Now we can virtually command the spark timing to do whatever we'd like and do it almost instantly in our programming. And the spark timing movement, let's say 10 degrees of movement, which can be commanded in microseconds within the programming here, that can have an immediate effect on the engine's torque output. So we'll find the fast path is generally what we prefer to try to manipulate when we're talking about our idle control routine to get the engine torque output to where it needs to be regulated at that, wherever the torque amount is going to be to hit the desired engine speed. So what we find here is that we have two different ways we can manipulate torque. We have a slow path and we have a fast path. Fast path is typically what we use, and in real time we speed up the control and vary the spark timing in idle conditions so that we have more of a fine adjustment on the engine's torque output to get us to the desired idle speed. And we utilize the airflow as a slow path of control in the torque output.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.